Hello everyone and welcome to today's presentation. I am Paras Norial and the topic for my presentation is Federated Learning. Before understanding federated learning, let us understand how a typical AI model is trained. A large amount of data is collected through sensors, devices, and other means of contact and survey. All this collected information is sent to a central server that has sufficient compute power. This data is pre-processed and a model is trained. The trained model is then deployed to client devices. But there is a major problem with this centralized method of training an AI model. Companies and individuals may have concern about data privacy while sending their information. Because the data is so huge, there is a delay in network communication or latency in data transmission. Being a centralized server architecture, this method has potential for a single point of failure, meaning problem in central server leads to clients losing valuable information. The whole process of sending, collecting, compiling, pre-processing, and deployment makes the humongous task of model training quite time-consuming. As you can see in this example, a central cloud-based server collects all the data from clients and sends trained model. It is clearly visible that there is a lack of communication and privacy in this approach. Well, now that we understand the problem, what is the solution? The solution is federated learning. This is a decentralized method of training ML models. In this method, a model is trained on the client's device that has all the sensitive information. Only a trained model is then sent to a central global server. This way, data privacy is maintained and valuable insights from trained model are used. While in the traditional approach, data is brought to the model, in federated learning, model is brought to the data. Here is a basic overview of the federated learning process. Hopefully you get some idea about this technology. I am going to explain the working in the next slide. Let us understand the working of federated learning through this informative graphic. First, the server initializes the parameters and hyperparameters of the global model. It then activates clients. Clients receive parameters and update their parameters through the local model trained on the machines. The updated parameters are sent to the global model for aggregation. The global model then updates the parameters for next round of training. Let us consider an example. Suppose there is a group of companies that wants to collaborate and train an AI model to predict market trends. However, they may be skeptical to sharing private sales data or other sensitive information. In this case, the group can use federated learning. Individual companies can train AI model on their machines and update the trained model on the global server. Doing so provides the trends in the sales in the trained model without exposing the information it is made from. This way, all the companies benefit through collective information without having to worry about data privacy. These are the companies that are currently using federated learning in their projects. Federated learning also offers several advantages, but it also has some limitations and challenges. Communication overhead. Federated learning requires frequent communication between the central server and client devices. This communication overhead can be significant, especially in scenarios with a large number of clients or slow network connections, potentially slowing down the training process. Heterogeneous data distribution. Federated learning assumes the client devices have similar data distributions. If the data on client devices is highly dissimilar or imbalanced, it can lead to convergence issues, making it challenging to create a globally accurate model. These were the limitations. With this, I would like to end my presentation. Thank you for your time and listening patiently.